Welcome you all to the Spark Research YouTube channel. This is Dr. Vishan, Assistant Professor in the Department of ECE, and in this session we are going to take some questions from the past year. And so here is the overview of this course in electronics devices of this GATE syllabus, right? So in this session, let's start to take some questions. So we are going to take the questions from the past to past, that is my 2024. In the previous session, we have already discussed what are the questions has been asked to the previous year, that is 2025. Pattern is almost same, so you can check it here. Total marks will be of 75 marks, and there will be the three parts. Part first will contain the 20 MCQ. Part second will contain the five short type of the questions. Each questions will be of 8 marks, and then part C will contain the two questions. Out of the two questions, you have to solve only one question, and that will contain the 15 marks, right? So this is the pattern. That is the question. So first question, that is 21, you can see here, find the concentration of the hole and electron. You have to find the hole concentration of the electron hole if the given is conductivity is given, and these values of like Ni intrinsic capacity, intrinsic carrier concentration is given, then the mobility of the electron and hole is given. Also you have to find the discuss the drift and the diffusion, right? So how will you solve? So since conductivity you can find using this equation, that is conductivity is equal to mu and E. Mu is the the probability, and N is the number of electrons, E is the charge of the electrons. Use this equation and find the value of the N, so you will get the the N type of the concentration. Since like Ni square is equal to P into N, that is a concentration of the holes and electrons. So using this, since we already got the concentration of electrons, so you can put and get the concentration of holes, right? For p-type substrate, similarly you can use the same equations. Conductivity is equal to mu Ne, and calculate the remaining values. Okay. So, and in the same questions like drift current, what is the drift you can find here? So current will be because of the two types, that is one is the drift and another is the diffusion. Diffusion is equal to due to the concentration gradient, and drift is your J is equal to mu Ne. So this equation already we have used. So here another question is that discuss the silent features of the power transistor and the power MOSFET. Second one is that what is the impact diode, right? So power MOSFET, whenever we are talking, this is nothing the normal MOSFET which will works at the higher voltage current, that's all, right? So the characteristic is similar, the output characteristic, and this is the switching characteristics, right? And impact diode, you can see here the construction, design construction. So here P N I N plus is there, right? So P plus, that is holes concentration is high, electron concentration is high in the N plus region, so doping will be very high. That is why plus term is used. I is the intrinsic, N is the fifth group element doped in the intrinsic, right? And the characteristic will be similar to the gun diode type of the characteristic. Okay. So draw the here now the astable multi-vibrator. Second question is that negative clipper. Okay. So here we can see here negative clipper is there. Clipper means you are going to use the diode, nothing else. Okay, and you are going to collect the output here. So here voltage battery is also there. So it here the negative will be clipped up, and so that is why negative clipper circuit is there. Okay, multi-vibrator, you can check the contents in our third unit contents we have discussed. So here is the general multi-vibrator circuits, and here it will be of three types multi-vibrator circuits, maybe the astable, bistable, monostable. So here depending on the stability you can check it here, it will form a stable or monostable, right? So here the and now we are going to talk about the fabrication of the double-sided plated through hole, and second question is that what is the electrical design consideration of PCB. So double-sided PTH circuit on the both sides, of course, then connected by metallization wall of a hole in the substrate, and popular where the circuit complexity and density is high, not very high. Also we can use the multi-layer, right? So contacts are made by the soldering components laid on the both side of the board. So no number of the solder joints to be kept minimum on the component side in the case of the removal. Okay, so double side PTH or non-PTH. So PTH like a plated through hole, and non-PTH. In the case of double-sided PCB, if we want to connect tracks on the top face of the PCB with tracks on the bottom face of the PCB, we need to punch a hole through the PCB, that is PTH, right? This hole should provide an electrical connection between the copper on the top and the bottom on the copper, right? The way that can be done, that is hole aligned with the conducting material such as copper, so that is why this is called the plated through hole. What are the benefits of the double-sided PCB? Of course, density is high, then double-sided PCB are widely used components for various applications as it enables more flexibility in the design and more complex circuits. Here are the few advantages. So the main benefits is that you have an extra layer and you can add the more components. Double-sided PCB boards tend to use more complex circuits as there is a more space, and being able to use both sides of the PCB effectively reduce the size of the boards needed. Next question is the design consideration, electrical design consideration of PCB. So conductor width is determined by components packaging density, minimum spacing between conductor and component, right? Geometrical constraints due to the component outline, and the registered dimensions are important here, so you can check that what is the dimensions required. The resistance of the conductor considered as a metal section having a rectangular cross section depends on upon the specific resistivity of the copper, which is like 1.72 to 10 to the power minus 6 ohm centimeter at 20 degrees. So similarly, you can see the the requirements for inductance and capacitance. Now let's take the content, the one next question, discuss the problem in the PCB for digital circuits and design rule for PCB for microwave circuits. So for problems in digital PCB circuits is the reflection, crosstalk, signal noise, interference. We have already covered all these topic in the our previous discussion. So you can follow the contents from the fifth unit. For PCB design for microwave circuits, here you can check it here. Actually, the critical component placement is required to minimize trace lengths. Place ground via the directly by the pad, and conductor geometry also it will matter. Say advanced microstrip antenna like patch antenna, and power divider is also there. Filter, you can use a stub filter, stepped impedance, and biases. So here is 26 number question. This is a numerical. So first talk about the energy meter and then full wave rectifier based on numericals. So here full wave rectifier based circuit is there. So IM, that is you can use the VM divided by R out. So you can calculate it here, and IDC, that is equal to twice of IM divided by pi. So average and IRMS, if you remember these equations, you can find it very easily. Energy meter, that is energy is equal to power into time. Okay, so then next question is that you explain the steps involved in the monolithic fabrication process. So silicon wafer oxidation, preparation of the wafer, then undergoes with the oxidation process, go with the photolithography, etching, doping, then metallization, and final packaging. So for more details, you can go through that details in the fifth unit slides that we have discussed in the regular session. Okay, so play today, stay healthy tomorrow, and learn for a lifetime.